Hello everybody. Today I am going to be talking about the Indian Plate. So I'm talking about this guy right here. The Indian Plate is a major tectonic plate located in the northeast hemisphere, and it is bounded by 4 other plates. So to the north here we have the Eurasian Plate, and then to the southeast we have the Australian Plate, and then to the southwest we have the African Plate, and then to the west we have the Arabian Plate. So these 4 plates actually used to form the supercontinent of Gondwana, but then they broke up. This made the Indian Plate start to drift northwards towards the Eurasian Plate, and the Indian Plate actually moved at a very high velocity of about 18 to 20 centimeters per year, whereas the African and the Australian plates were a lot slower than that, at only about 2 to 4 centimeters per year. And it is believed that the Indian Plate had such a high drifting velocity because it had a really low lithospheric thickness. It was only about 100 kilometers, whereas the other plates that formed Gondwana had a higher lithospheric thickness at about 180 kilometers. First, I'll look at the Indian Plate and the Eurasian Plate, their boundaries. So, like I said, the Indian Plate was traveling northwards, and this made it collide with the Eurasian Plate. So these two form a convergent boundary. And this collision happened about 50 million years ago, and it actually caused the Himalayan mountain chain, which contains the highest peaks in the world. Another result of this collision was actually the creation of a lot of smaller plates in the eastern boundary of the Indian Plate. And I think that this collision between the Indian Plate and the Eurasian Plate is a good example of continental to continental crust convergence because of the Himalayas. The Eurasian Plate was kind of crumpled up above the Indian Plate because of their low density and high buoyancy. So neither one of the plates could really be subducted. This then caused the continental crust to thicken due to compressional forces pushing up the Himalayas. And the Himalayas are actually still rising up by more than 1 centimeter per year because the Indian Plate is still moving northwards into the Eurasian Plate. Next, I'll look at the Indian Plate and the Arabian Plate and the boundary that they have. This is a transform boundary at what is called the Owen fracture zone, although that is misnamed a fracture zone and is just a transform fault. Here, the Arabian Plate is actually moving northward faster than the Indian Plate. Since this is a transform boundary, you are likely to see some offsets in topography there. Next, I will look at the Indian and the Australian Plate boundary. This is also a transform boundary. It was previously thought that these 2 plates were actually one single plate because there wasn't really a clear type of boundary there, but recent evidence actually suggests that it's a transform boundary because their drift velocities are different, although both of the plates are moving in the same direction. Now we have the Indian Plate and the African Plate boundary. This is actually a divergent boundary, so these 2 plates are being pulled apart. And I'm not exactly sure what's there, but since it's a divergent boundary, I would assume that earthquakes would be common here and that magma is rising up to create new oceanic crust. Yep, that is the Indian Plate and its boundaries.